Okay, welcome to the lab 4. In this lab, we're going to go into the assembly language. So if for assembly language, we need to have the software, which is MCU 8051 IDE. For this software, you already uploaded in the spectrums. You can go to your spectrum and look for the installer for this 8051 IDE. You can download it and install on your own PC or laptop for future lab sessions. So from lab 4 onwards, we are going to use this software until the end of the lab sessions. So this is basically software development for the microcontroller 8051 from Intel. This is a very old IC, but it consists all the basic assembly language we're going to learn in these lab sessions. And the programming language we're going to use in the lab is the assembly language, which is considered as the lowest level of language to write all the program. And unfortunately, we don't have the hands-on lab which using the hardware. So what we're going to do is only using the lab simulations to let you all know how this assembly language works and how we are going to create some simple program and for our applications. So as you can see, this is the instruction of the 8051. It's a list of instructions. So you can get this instruction set from the 8051 datasheet in the spectrum also. Basically, they are telling you in the datasheet, they are telling you what are the functions of all these instructions. And basically, assembly language, they are more similar to the abbreviations of the functions of the instructions. So for example, like if you want to move something in our memory, we want to move a data, so we can using the MOV to move data from one location to the others. Okay, then if you want to multiply, is equal to MUL. So it's just a short form of multiply, the MUL. This is a short form of move, right? Then you want to call something, call a subroutine or call a functions. It's just using the a call, assembly call. Then you want to go from one area of coding to the others, you can using the jump functions. Okay, so all of this we're going to go through in the example later on. Okay, so just to give a concept that this is the assembly language, which is the lower level language, and we're going to start learning this one in the lab sessions. And so here, this is the sample program of the assembly language, and they basically divided into three parts. The first section is the label, right? Then the center one, this one is called the instructions. Okay, this is all the instructions we just seen just now, right? The jump instruction, the move instructions, and yeah, the third part is the operator, or we call the operand. In the normal way to start the program is start with the origin, the starting address. So in this example, the starting address we're going to use is using the 00. So this origin is just the origins where you want to start to store your program at which location of memory. So what we do is put the origin at the 00, and when you see the hash in the program, this means the hexa number. So mean this number is referred to the as a hexa numbers. Okay. Then they start with a jump, mean absolute jump. They want to jump to where? So they will jump to a certain location, which is using the label to assign. So in here they said we're going to jump to main. So they will when the microcontroller decode these instructions, they will look for the main. Where is the location of main? So they will see the main is here, so they will come to here and execute these instructions. Okay, so it means they will go to the main, go to this label, jump to the label, and execute the instruction at the same line as the label. So in this instruction is a move to A00H. So when there's a hashtag here, means this is referred to as a a number. Okay, number. So what are the number? Is 0 0 and is in terms of hexa. So it means they are moving 0 0 into the A location. A is just one of the register in the microcontroller, a storage, a 8-bit storage register. So the IC we're going to use, the 8051, is a 8-bit microcontroller. So most of the register inside this microcontroller is only 8-bit size. Okay, so they will move 0 0 into this register A. Okay, so by looking at this example means you're moving something from the source. So this is the source to the destinations, which is A here. Okay, so the move instruction is this way. The second operand is the source. The first operand is the destinations. You want to move something from the source to the destinations. So after you move to A, then the next line, the sequence of execution is in sequence. They will go line by line unless they see the instruction called jump. Then only they will jump to the locations pointed by those instructions. So if there's nothing happens, so they will, after I execute this move, I will go to the next line to execute the next move, next instruction. So in next instruction is also a move. So they move A into your P1, sorry. So means they will move the content in A into the P1. So at this instruction, your A is your source. So they will move the content in your A into the P1, which is a port 1. We will look into what is port 1, which is basically one of the port of your microcontroller, which is connected to the, is able to send data out. But register A, we cannot access it from outside. It is located inside your microcontroller. So this is your register A. It's just a register storing data. But port 1, they are basically connected to the pin of your microcontroller. You are able to access this port 1 data by using the outside circuitry. Okay. So now they move from A to P1. So at the end, your P1 will equals to 0 0. Right, they move 0 0 into A, then after that they move A into your P1. So means they move 0 0 into your P1. So this is one of the way of transferring data in the 8051 microcontroller. They are not allowed you to directly moving data numbers into the port register. Any P1, P2, P3, P4. There's 4 ports in this 8051. Okay. They are not allowed you to move data directly into the port. So what you can do is only you need to go through the register, which is a A register or B register. There is 2 registers. We are going to look into it after we go into the details of the microcontroller. Okay, so every time you want to move numbers into your port, you must go through either register A or register B. So you need to move the number into A, then only move A to the port you want. Okay. So after you move to the P1, the next, they will go to the next line. They move another numbers 5 5 into A again. Then they move it into P1. So this is the function is equals, in high level it will equals to P1 equals to 55, and this one is equals to P1 equals to 0 0. But it's in hexa. Okay. After you finish this one, the next line come. They will ask them to jump to start. So they will look at the label. Where is the start? So start it here. So I mean they will look back into here. So they are keep looping in these 3 lines. Right? After execute this one, come to here, then come to here, then go back to again. Okay. So after you finish the program, you must put an end of program to tell the microcontroller the program has end at this point. Okay. This is one of the short example of how to do the assembly language program in the 8051 microcontroller. So in this 8051 IDE, they also giving you a lot of virtual hardware available. So you can see there's a LED display, 7 segments. This is for 1 segment only. This is 4 segments. Then we also have a simple LED lights on and off, just like what the LED you use in the Tinkercad. You can see there's a register here, then there's a LED symbol here. So it means they basically a register pass through a LED, right? Then go to your port. Okay. Then they also giving you the push button switches, on and off the push button. We will use all these virtual hardware in the next few labs. So after you have installed, you can follow all the instructions on how to create the new project. So you go to project, then go to new, then you fill up your project name. You can put any project name you want, but put it in short, it will be better. Then you find where you want to store your program, the location to store a program. Then you can select your processor. So the name of the processor we use is this one. So you put this name and just click OK. Then you will come up to this page. Yeah, you will come up to this page where you can starting to type your code in. So this is the first example code program. You can start to type this program. Then you compile the code to check whether there's error or not. Okay, so this is basically the lab 4 starting. There's no assignment given on this lab 4. What you need to do is just to install and try this software and similar. Try to use some of the virtual hardware there. Okay, so I think that's all for the lab 4.